Good morning, everybody. And in this presentation, I will talk about the ETICS tool and how we are going to we are using the tool in the OCCI project to support the testing of interoperability and the compliance to standard interfaces of software in general and cloud components in particular. So there will be another presentation about the OCCI project in the afternoon, so I want just to say a few words to contextualize the project. This project is a support action project funded by the European Commission, and one of the main objectives of the project is to build a directory, a web directory of open source cloud-related software that are outcomes from research projects, both European research project and national research project, with a particular focus on interoperability and quality of the components. So we want to build this directory to let the user to browse the catalog and select cloud components that they need for building, for instance, their own cloud infrastructure. And we want to provide also quality metrics and reusability and interoperability analysis of these components. And for doing that, we are using the ETICS tool to extract directly from the source code part of the metrics that we published in the directory, and to support, we will see in this presentation in particular, to support interoperability testing of the components. So just a few words about ETICS in general. ETICS is a build and testing automation tool. So it means that it takes the source code from the source repository and compile the code, run tests on the code, produce packages, binary packages of the components, and publish the packages on a public repository. It is completely web-based, so there is a web portal from where the user can instruct the system to do all these steps in an automatic way. And it's independent and it's agnostic from programming language, platform, or building tool. So it can build components that use Ant or Maven, or that are written in Ruby or Scala. And since the tool has a pool of resources that use for building and testing of the components, these resources run different platforms, different flavors of Linux, for instance, or also Windows. So the developer, the user, can choose on which platform he wants to make the build and the test. And there is a dependency management mechanism, so you can specify dependency among components in your project. There is a built-in packaging system that produces binary packages from the compilation, both in different formats, both in tarboards or RPM or Debian, depending on the targeted platform. And as I said, there is a public repository for all the outcomes of the compilation and testing. And finally, it is also extensible through a plugin mechanism, so we can integrate different tools for doing specific testing during the testing phase. So coming to the testing capabilities of the system, we have different kind of tests that are supported by the tool. We start from the static analysis of the source code. As I said, through the plugin mechanism, we integrate some testing tool for static analysis, like check style, find bugs, or PMD, CPP check for different languages, of course. and these are the most popular. ETICS provide also the runtime environment for executing the unit testing, like JUnit or PyUnit testing suite that are available in the source code when it compiles it. There is also support for functional custom, let's say, functional testing written by the developers, and ETICS can execute it, detect it in the code, execute, and produce some reports. And finally, this is actually the main point that I will talk about in this presentation is the multi-node test. What we call a multi-node testing is a functionality of the system that allows the definition and the execution of tests that span over multiple resources, multiple nodes. We will see later, but it's really, useful for testing, for instance, client-server applications. Just a word about the reporting. Every build on test produce reports that are both in XML data for later processing, for instance, and HTML version for visualization. So here, for instance, we have a build for some components of compatible one. We have all the components and a summary of quality metrics. But if we click and go deep in the reports, we can have the values for all the metrics extracted by the plugins, and where available, so a trending analysis for a specific metric. Okay, coming back to the multi-node testing, as I said, ETICS provide a support for this kind of tests and provide some facilities for defining and executing and managing the execution of tests that are executed on different nodes. So it's really useful, as I said, for testing a client-server application. For instance, if I have a client-server application, I may want to test by deploying the server on one node, deploying the client on a second node, and check the communication and check that both the components behave as expected and communicate as expected. And even from here, it is quite clear how this can help the interoperability testing between different components. That is the goal we want to achieve in the OCCI project. Some other characteristics of this multi-node testing, as I said at the beginning, everything is done through the web portal. So the user selects the number of nodes that he needs for the test. For each node, it selects the components that he wants to deploy on the nodes, and then specify the testing scripts, which are the scripts that actually are executed during the test. The benefit, of course, the benefit of running this test using ETICS is the automation of this test. So you define the test one time, then you can execute it multiple times using different version of your software. When you develop new functionality, you can run again the same test like we do for unit testing, using different. You can target different platforms, and or you can also use some parameters in the test, and you can give a value to this parameter at runtime. So you can have this kind of parameters. And then all the tests are executed on nodes that are created by the ETICS system. So the system control, its own infrastructure, and can create and destroy nodes for the test. And this assures, of course, that each test starts from a clean test bed, from a clean node, so all the tests are repeatable. Okay, I think a fundamental characteristic, a fundamental support for this kind of testing is the synchronization of the testing scripts on the different nodes. Because, of course, as you can imagine, if I want to test a client-server application, when I execute the testing script on the client, I want to be sure that the service is already up and running, otherwise the test would fail. So ETICS provides a synchronization mechanism, very simple mechanism with these two primitives, these two commands that allows to publish a value from one node and to retrieve the same value published on the other node. And the nice thing is that the get is a blocking call, let's say, so the script will wait until the other nodes publish the information. This is very basic synchronization, but in some way it's very powerful because it allows to synchronize all the testing scripts to run the whole test. There are also some other synchronization primitives, more abstract, like synchronization primitives to transfer file from one node to another one. So the first node publish a file and the other one wait until this file has been published by the first node. But I think that with these two, they are enough for most of the cases. So just to give an example, let's say I want to test my Java web application, and I define a test with two nodes. The first node I want to deploy, I specify that I want Tomcat on the first node, and I want to deploy my application on Tomcat, and then I start the server and publish the endpoint of my application. On the second node, I retrieve the endpoint of my application, and I write some test for testing the application. I can interact with the application and check that it's up and running and it's behaving as expected. And the nice thing is that my web app here, the package that I deploy, comes from the continuous integration part of the ETICS system. So it's always, let's say, the latest version available. You can specify which version you want to use. You can specify that you want to use the development version, for instance. So every time you build a new version, you can run this test and have the tests executed with the latest version available of the application. A kind of continuous deployment testing, let's say. Here we have another example, maybe a bit more complex. I did it as an exercise, let's say. I deployed a Cassandra cluster with two nodes. One node is the seeder, the other node registered to the cluster. Then we have another node that fill the database with some data. And the fourth node, actually, it's a client which check that the data has been inserted in the database and queries the database. And as you can see from this screenshot, you can define the testing commands directly through the web interface. This is fine for the simple cases, let's say. But of course, if you have a more complex testing script, you can write your own script and upload it on a Subversion repository, for instance, and ETICS can download the script and execute it. So, sorry. These are all the ingredients of the multi-node testing in ETICS. Now we are going to use these capabilities of the system for supporting the interoperability testing in the OCCI project. As I said before, in the OCCI we want to test the interoperability between cloud components in order to publish this information on our cloud directory. And I say it's support here because, as we heard today, but also yesterday, interoperability is not just a matter of technology. It's not just interoperability at level of technology. Of course, there are other issues, for instance, for licenses or contracts and so on. But at least for the technology part, technical part, ETICS can support this kind of testing. And again, here, running this test with the ETICS tool, we can, of course, automate the test, but we can also have the chance for, the opportunity of, we define the test and we can run the test using different software, and we can check in this way the interoperability between different software at the same time, using the only one definition of the test. And then finally, since most of the time in cloud components, interoperability is achieved by interfaces, standard interfaces, we are looking to testing suite for OCCI. There are a couple of them. Since OCCI is one of the emerging standard interface for cloud computing. So we are looking at these two testing suites. Both of them are endorsed by OGF. We plan to collaborate to extend these suites, because sometimes it's not, they are not complete. And finally, we want to integrate it with the plugin mechanism in the ETICS tool in order to give the user the possibility to define a test to check the compliance to OCCI, simply by using this multi-node testing capability that I presented today. Well, I'm done. Just a recap of my main points. Okay, here we have some references. This is the web page of the tool. This is the open source, open cloud directory that we are building with the OCCI project. By the way, I encourage you to take a look at it if you are looking for cloud components that you want to use in your project, or if you have a project, an outcome from a project that you want to publish on the directory. You can go and register for free, of course, and publish the information and share your component. Okay, thank you.